Today I'm going to be talking about remainder theorem. So remainder theorem states that if a value of x is substituted into a polynomial equation and the outcome is 0, this value that you substituted into the equation is going to be a solution for this polynomial. Solution, root, 0, they all mean the same thing. They're all going to be x-intercepts on our graph, and therefore solutions to our equation. So I'm going to show you an example, and hopefully that'll kind of clear up the definition a little bit as well. So I'm going to take the equation y equals x cubed plus 7x squared plus 14x plus 8. And say we sub in the value x is equal to -1. That value was given to us in the question, and we're asked to substitute it into the equation. So every time you see the variable x, you're gonna substitute in -1. So -1 cubed is still -1. -1 squared is +1 times 7 will be 7. 14 times -1 is -14 plus 8. And if you do this either in your head or on your calculator, this is going to come out to equal 0. So since when we plugged in the value of x equals -1 into this equation and our outcome was 0, this means that x equals -1 is a solution of this function. So that means the corresponding binomial for it would be x plus 1, and like I said before, it means on our graph some sort of polynomial, we have an intercept at x equals -1. Now I'm going to show you an alternate way to prove remainder theorem. So we're going to use synthetic division. So we're going to use the same we're going to use the same equation that we were using in the previous question. So that's the y equals x cubed plus 7x squared plus 14x plus 8. So that's the equation we're going to use, and now we're going to use synthetic division. So when you're doing synthetic division, so we're dividing this by our x value. So you pop that here. And then you're not going to write the variables in here, the x's, you're only going to write the coefficients of each of these. So here the coefficient is a 1, 7, 14, and 8. So synthetic division is pretty simple. You pretty much just multiply and add, multiply and add. So the first term you just bring down here. -1 times 1 is -1, and then you're going to add these two together. So it's going to be 6. 6 times -1 is going to be -6. Negative 6 plus 14 is 8. 8 times negative 1 is negative 8. 8 plus negative 8 is going to give us 0. So since our last number here is a 0, this number represents our remainder. And since when we did our synthetic division of this polynomial by negative 1 and we got a remainder of 0, this also proves that x is a 0 or a solution or a root of this polynomial. Now we're just going to take a look at a question that is kind of an application of how you can use remainder theorem in some problems that you might see. So the question is, the polynomial, which is this is the polynomial kx cubed minus 10x squared plus 2x plus 3. So this polynomial has a factor x minus 3. So whenever you're given it as a factor, you always have to think, okay, so that means that the actual x-intercept is what's going to make this equation 0. So it would be 3. So this is our binomial factor. And you can also think about it as like actual x value on the graph is going to be 3. So we know we have this polynomial. It's got an unknown value k as a leading coefficient. And we know that it has a factor of x minus 3. So when a polynomial has a factor, we know that the remainder is going to be 0. So what we can do is substitute in our x value where we see an x here, and we know that since it's a factor, the outcome is going to be 0. So we can just rewrite it. So k, we still don't know, but we can substitute in our x value. 3 cubed minus 10, 3 squared, plus 2 times 3, plus 3. So 3 cubed is 27. 3 squared is 9, times 10 is negative 90, plus 2 times 3 is 6, plus 3. And so we know that this is going to equal 0. So now we can bring all of our constants to one side, which is going to be 81. And now we want to get k by itself, so all we need to do is divide 27 by both sides. And our k value is going to be 3. So using remainder theorem is really helpful in these types of questions because they can help us solve for unknown values in our equation.